Okay, we're going to begin the world of anti-derivatives, but before we do, I want to refresh your brains on the commands that you know now. And commands, by commands, I mean operators. Symbols that say, do this, do that. That's what operators are. They're commanders. They tell you what to do. Hate it when people tell me what to do. All right, so there's the evil plus sign. You must add this to this. It's a command. It's an operator. Subtract sign, multiplication sign. And multiplication sign is tricky because you can have parentheses touching something. That means multiply. You can have an X, although usually by the time you get to algebra, you don't use the X anymore. Anyway, those are operators or commands. The divide symbol, which also is a fraction bar, that means this, divide this. So up until calculus, essentially, these are the four operators that you know, right? And then the beginning of calculus, you learn this operator. This phrase right here says, take the limit or find the height. That's a command. That's an operator. Then, most recently, you found this. There's this operator, d over dx with the function attached to it. That means find the derivative or take the derivative. It's a command. Do this. Now, I'm introducing a new command or new operator, and it's this symbol right here. So, this summation symbol paired with dx, those two paired together, and they must be together, mean integrate. So we're going to be working on integrals, but before we work on integrals, there's the process of finding an integral, which is antiderivatives, meaning you found the derivative, now go backwards to find the function. And so let me go over this too. So up until calculus, I need to ungroup this, hold on. Sorry about this. This is taking the next few seconds that I hadn't planned on. All right, so we have the position functions. So when you type a value in for x, you get the y value. So f of x means y is equal to x. If I plug 5 into x, I get y. Then we have x squared. If you plug 5 into x, x squared is 25. Y, or f of x, is equal to 25. That is a position. The y value is the height. So a lowercase f of x is the position function. Then in calculus, we learn instantaneous velocity, which is the derivative function. When you take the derivative, and these are the derivative of each of these functions, when you take the derivative of the position function, you get the function that produces instantaneous velocity or slope of the tangent line. They mean the same thing. So now if we plug values in for x, that gives us a slope value. Now we're leaving derivatives, sort of, and we're going to now be finding antiderivatives, and its notation is capital F of x. And that notation means find the integral, and the integral is area under a curve. So look at what happens if I cover these up for just a second. The antiderivative of 1 is x. The antiderivative of 2x is x squared. The antiderivative of 1 over 2 square root x is square root x, and the derivative of negative 1 over x squared is 1 over x. Look at the original position function. So the position function goes to the derivative to the integral is the antiderivative. Well, the antiderivative goes back to the position function, however, which is really weird and it confused me for a while, but this is why notation, I say to you all the time, notation, notation, notation. When it's lowercase, it is just a function problem and we're looking for height or just a point on a graph. When it's capital F of x, so if you've got a graph that looks like this, between 2 points, this capital F of x tells you to find the area underneath that curve. So lowercase f, so they look like the same function, but these commands, this capital F of x, which is in, will end up being in this notation, capital F of x, and then here's the command right here that says to integrate. That's what will give you the area under the curve. So let me show you. So here's the command notation, and right in here goes in whatever function you want to take the antiderivative of, but the notation is the summation with this d of x. That's the command to integrate. And learning how to find the antiderivative leads to integrating. So capital F of x is the integral notation accompanied with the command find the integral of this function. So this phrase right here working together means find the integral. And then pretty soon we're going to be working with upper bounds and lower bounds, but I'll talk about that a little bit later. And then graphically, this is what we're talking about. So this notation right here, f of x is equal to the integral from a to b of f of x of dx. Find the area underneath the curve between a and b. The integral is finding the area under the curve, but before we get to actually finding the integrals, we have to figure out this piece. How do we differentiate? And that's what we're going to be doing next. But for this video, that's it.